As you might have already seen from the title of the video, this is not your typical Android development video. I just basically wanted to talk about application, hobby application that I built using LangGraph. It is agent. It is a AI agent which helps me to do certain things when I am working with YouTube. So let me talk about what exactly the problem that I was trying to solve. As a YouTuber, when you record it, edit it, and then put it on YouTube, publish it, that's not where the work actually ends. There is a lot of post-production work that you will have to do when you upload a video. For example, you will have to create captions, you will have to correct the captions, then based on that generate the chapters, appropriate description, come up with the titles, and then try to make them optimized for search engine. So your titles will have to be SEO optimized, and then you will have to come up with some thumbnail ideas, and list goes on and on and on, because you have to do this, because if your YouTube algorithm is supposed to show that particular video in the people's feeds, this is something that you will have to do. And this is very repetitive, non-creative work, then it has to happen every time you upload a video. So I wanted to come up with application which could help me automate all of these things, and that is what the actual main pain point was that I was trying to solve. You may say that tools might already be there which actually do this or help you to automate this to some extent, but then I wanted something which actually is well suited for my workflow. I have been following a particular workflow which suits me and which I have refined it over a period of time or many years. And if I start using a tool which is out there in the market, probably it might not suit my workflow. So I wanted something which suited my workflow. That was the main motivation to build this particular tool. And also, there is a bit of fun in building your own stuff on technologies and frameworks which you are not familiar with. So it's a very good opportunity to learn something, and why not build something and learn something that can be of useful to you in your personal day-to-day life. So let me quickly show you what I have actually built, and then I will talk about later in the video the technical aspects, how I built it, what were the learnings, and if at all you are interested in agentic development or AI enabled development or building AI agents, agentic flows, then probably this is something that might be of interest to you. So let me show you what I have built. So what you are actually looking at is the terminal window of the VS Code, and let me enter creator ops. It is very similar to DevOps, but here it is operations for the YouTube. So that is why I named it as creator ops. And then it basically triggers the application. And I have implemented it as a REPL application because I just wanted to quickly get to something which I can use rather than trying to build a complete scaffold of UI and very complicated stuff. That's not what I was interested in. And REPL is a command line interface, and as a developer I think I would prefer this to a web browser because it makes me work much faster. And then I want to basically update the video metadata that I already have in my channel. So let me show you what do I mean by that. So this is one of my very old video about broadcast receiver, and you might have seen that this looks pretty bad, the title, the description, and everything, and I want to basically improve this. So what I will do is I will write a command in the REPL, something like this: process video. This is the video ID, that is the video ID that I am talking about, and then I will say for proofreading, chapters, description, SEO, titles, thumbnails. So basically what I have done is what exactly I want out of this particular video, what I need to be processed. And then I just hit enter and you just wait. So it goes through the parsing request, it fetches the captions, and it detects the GitHub links if at all there are any demo GitHub links that I have in the video. And then it proofreads the transcript, generates the chapters, it generates the description, generates a set of SEO titles, and selects one of the title as the ideal candidate, and it generates at least 3 thumbnail ideas, and those 3 thumbnail ideas actually get converted into a thumbnail prompt itself. So this is how it all looks like. You can actually see it here. So today is 22 and this is the folder that it created, and this is the chapters it created, description, proofread transcription, that is the transcript, titles. This is the selected titles, but it generated around 5 titles. And if you don't like this selected title, I can actually choose one of these and copy paste it here in the selected title. I think I would prefer this one. Let me copy this and paste it here. I will make it broadcast receiver 2. This is a slightly better title. I save this, and then I have thumbnail ideas and actual thumbnail prompts. So I am good with this. If you want to revise something, you can enter revise here, but I am good. Then what I will do is I will say publish and hit enter, and that's it. And now if I come back to my Android Studio here, this is what you are seeing, old data. Let me refresh this page, and now I have the complete new metadata available, updated. Earlier this used to take quite an amount of time. I mean, before ChatGPT came, this used to take at least 2 hours. And after ChatGPT came, I created my own prompt, and from 2 to 3 hours, it got reduced to almost 40-45 minutes. But it was still a drudgery to do this for almost each and every video. So what you just saw was about the video part. This application also does another thing. It creates the description for the playlist. My YouTube channel has got lot of playlists. Playlists are basically arranged based on what you are trying to learn in that particular concept. So this particular thing is basically talking about composable state. This description and title creation takes time. Based on the number of videos that are there in that particular playlist, I will have to write the description, I will have to come up with the title. I wanted to make sure that can I automate this as well, and that is what this REPL does very well also. So let me just go back here, let me clear, I will write another statement, process playlist. This is the URL of the playlist for description and title suggestions, and then just hit enter, and it basically goes through all the videos that are there in that particular playlist and then comes up with the playlist metadata. So that is this particular video. This is the description for that particular playlist. This is the title, Jetpack Compose State Management with Remember and Remember Saveable. I think I like this one. Let me see what it has selected. Yeah, I will replace this, and then I am happy with this. And now what I will do is hit publish and enter. The metadata got updated. Let me show you in the browser and refresh this. Yeah, all the information, description and title is updated. So as you had seen in the demo, it doesn't directly upload. The agent does its work, and then there is a human in the loop until and unless I review and modify the certain things and then I say publish. Until then, nothing gets pushed, updated or modified on the YouTube. And when it comes to building agents, this is exactly the kind of approach you have to take. You have to make sure that whatever to the maximum extent it is possible to automate the things using LLM, do it, but then you will have to take certain decisions at what point in time review gate will have to be presented to the human. Only after a human approves results, the actual final critical steps are executed. So you can think of this agent not like a series of API calls that we are making. That is not how it is actually working. There is a LLM involved here, and I have basically used a LangGraph and LangChain to build this particular thing. And you can think of it like a state machine, and the flow actually looks something like this. You give the video URL, and then you make a API call to fetch the transcript, and then you use the LLM to do the proofreading of the transcript. Before that, whatever the steps that you are doing, that is fetching the transcript and everything, it is all API call, YouTube API call. And after that, the proofreading part, this is where the LLM comes into picture. I am using OpenAI's LLM APIs. And then I use LLM to generate the chapters, description, titles, thumbnails. So this is where all OpenAI's APIs come into picture, and LangChain comes into picture to make the API calls and use the tooling and everything. And then finally you review, that is where the human in the loop comes into picture. And only after I approve, the YouTube gets updated, or automatically by default the thing gets saved to the file system, and I can go and modify in the files. And then if I want to revise, that is also possible. So basically, if you think about it, it's this particular loop that I am using in this agentic workflow. I generate the data, then I validate it. If I feel that it is passing whatever the threshold that I expect it to pass, then I use it. Otherwise, I revise. Now you might be asking a question, how did I build this? How much time it took? So let me answer a couple of those questions. I did not write a single line of code on my own. It was majorly done with the help of AI. I used Codex to do the major part of the coding, and then I used Copilot to do the review of the code. And why did I use two different LLMs? It was very intentional, because I personally feel if you continue to use only one LLM, there is an inherent bias in the way they think. Think of it like you would like to have two different people with different perspectives to have a look at the code. So I was using the Codex to do the coding part, and then Copilot to do the review part, the PR review part, and then fixing if any mistakes were there in the PR review. And this was not written using vibe code. It was all properly written using well documented PRDs. I can just show you a simple flow that I followed. The first thing that I did is I created a PRD, and as you can see, this is a version 2 of the PRD. So this is not the first PRD. There was another version, and then I refined it. And this contained a very detailed specification about what are the requirements, what is in scope, what is out scope, what are the important principles that I am following. Coming up with the PRD itself took quite an amount of time. And once the PRD was to my satisfaction, then I created a implementation plan. Once again, I used the AI agent to come up with the implementation plan. It had very detailed milestoning, and each milestone was put in the GitHub issue tracker. So if you see here, I have created a series of GitHub issues, and as and when a PR got closed and a certain milestone got reached, then I closed that particular issue in the GitHub tracker. And of course, this was all done using GitHub MCP server. So I'm using Codex, Copilot, and I'm using GitHub MCP server to basically manage the complete agentic workflow here. And then there are pull requests that are being raised by the agent, which are being reviewed by the agent, and which are being fixed by the agent. PR is raised by the Codex, review is done by the Copilot, and fixing is done by the Opus. And this, you cannot call it as vibe coded, because proper development mechanisms were used. Test cases were written, test cases were checked to ensure that nothing failed between each PR. So this is a very structured multi-agent workflow, not a vibe coding. This was properly tracked like a real project. And if I can say, I spent almost 1 month to come up with this particular application during weekends and during my commute time. But I would say the coding was not the major part. Writing the specification, coming up with the specification was the major part. I would say out of 1 month, probably initial 1 or 2 weeks I spent on understanding the problem space itself. That was the most critical part. Once I ensured the specs were as detailed as possible, then writing the code was not a big deal. Agent was able to do it in a pretty good manner. And output quality was properly tracked, and we had written a very detailed unit test cases. I can actually show you that all the unit test cases were being closely tracked as the application was built over multiple periods. So let me summarize what has been my experience by building this. One thing is, writing the spec actually felt like a different kind of programming. You have to spend lot of time with writing the spec. Don't get into the coding as early as possible. Coding is probably the cheapest and the easiest part here. You will have to make sure that you understand the problem space very well, you understand the each and nitty gritty very well, and if you don't understand, once again use LLM. So I used the LLM itself as a brainstorming tool. I spent quite an amount of time talking to LLM, asking queries, asking questions, counter questions, asking it to push back, or asking the LLM to confirm whether what I am thinking is right or wrong. And I did not use just one LLM for that. I use multiple LLMs because I just don't want to trust what one LLM says. And the output quality is mainly determined by the specification. The more amount of time you spend on specking out, the less amount of time you will spend on later trying to fix the problem that agent might do. So as they say, the more you sweat in the peace, the less you bleed in the war. Something similar can be said about agentic development as well. The more you spend time in specking out the application and problem space, the less time you will end up later fixing the problem or the mess the AI agent will create. And unit tests are not optional, they are compulsory. And also, unit tests actually work like a feedback loop for the agent, because even as a human developer, how do you know that whatever that you are writing is actually correct, or whatever that you have written hasn't broken anything that you had written probably a couple of weeks back? Unit tests. If unit tests fail, that is an indication that something went wrong while you implemented something new. And that is exactly how it works even for the AI agent. So agent knew it broke something because some of the unit tests started failing when it wrote something. And that is exactly the reason why I say unit tests are not optional even with agentic development. You will have to make sure that you are writing the unit tests, because without tests, agent has no signal across sessions to really understand whether something went right or wrong during its development session. So unit tests are agent's feedback loop. And then another thing, I had personally gone through a training on LangGraph and LangChain before I attempted to do this, because I wanted to be sure that I understand this properly, because you really need to catch if agent is doing something wrong. At least you should have some semblance of understanding what agent is doing. If you directly get into the coding without really understanding the underlying concepts of developing agentic workflows using LangGraph, then most probably you will not be able to identify the mistakes that it might do. So I think the human judgment is still very much important. So this was not a vibe coded application. I had personally gone through a training, self training, you can say, on trying to get the conceptual understanding of how agentic flows are built using LangGraph. So I wasn't blindly trusting the agent. I could read it, I could question it, and catch it when something was going wrong. So agent amplified my engineering judgment, but didn't really replace it, I would say. So I would like to once again emphasize that all this noise that we are hearing, that AI will replace engineers, I don't think so. The agentic tools will not eliminate engineering skills. They actually change what an engineering skill looks like. So in the earlier days, coding was considered the engineering skill. I think coding only as an engineering skill is no more of much value. Your ability to define the problem workspace, define the scope, build a system thinking around the problem space, and really get into the nitty gritties, and then most importantly, ability to catch the mistakes that agent will do or might do, validate, verify whatever the work that agent is doing. That will be the new set of skill set that developers would actually be expected to have in the upcoming days. So thinking precisely about problems, specking out the behavior, designing the feedback loops, knowing when to trust and when to question, those would be the new set of skills that would really make a difference between a average software engineer and a very good AI native software engineer. And that is still engineering, and that is still you who are doing, not AI. So yeah, that's it. Hopefully you found it useful, and please feel free to share your thoughts on this. Thanks for that. Brings watching us to the end of this particular video. Don't forget to like, comment, share the video and subscribe to the channel. Take care. Bye.